Hey, what's up guys? Today in this video, we are going to take our deployment to the next level. So today we will first push our Docker image to Amazon Elastic Container. This is the solution for Amazon to host your Docker images, and then we will use this image, which we will deploy to Fargate so that we can start our container, and then finally we will create a load balancer which will point to the Fargate so that the traffic can be routed to that particular container, right? So we have a lot to cover, and hence let's get started. So the first thing is obviously that I'll go and say create container. A repository. This is going to be the name, and let's create repository. Okay, I'll copy the URI and paste it over here. I'll tell you one thing, which is, before showing you this video, I have already done one dry run. So there are certain things which you may find already present on my machine, but I will point them out and tell you what will happen in case you don't have that. Okay, so when you create the repository, go inside that repository and you will find view push commands. This is very important because this will generally give you all the necessary steps that are required to push the repository. Now, while we are doing this, you need to understand that you require AWS CLI tool for everything that we are doing. The AWS CLI tool, you can get that if you search AWS CLI install for Linux. I think this is the one. Come on. Yes, this is the curl command, and then it installs, so you can use this. I have done something similar, so I don't see any problem with that. Okay, so once you have that CLI, you will need to then configure your CLI to have profiles where you'll create an IAM, and then using the keys, which is the there is something called as key ID and key secret, right? So these two things you will require to configure your profile, and this is the configuration required so that the AWS CLI has some kind of authentication before it can connect to your account and make certain requests, do certain actions. Okay, so you will be able to get them from here, configuring credentials. I think that's where you need to add the stuff, right? So when you do configure, right, you will be asked for the access key ID, access secret, and all those stuffs, which you will need to create through IAM. Okay, that is something which I'm not going to show you because I can't show you my IAM page. There are certain client stuff there which I will not be able to share. So sorry about that. But if you have any issues, you can definitely write down in the comments below and I will definitely help you. Okay, so first things first, we need to log in. The login is required so that you generate a token before you run these commands. So let's come over here and login password, username. This is all fine. Let's do that. It should show a success. Right? So yes, login succeeded. By the way, one thing which you can do to confirm that your installation and configuration is done properly is once you do lsal inside .aws, you will see these two files, config and credentials. If these two files are present after the configuration, you can assume that this is done properly. Okay, fine. So let's go back to these steps. So the first step, retrieving an authentication token and authenticate your Docker client to your registry is done. Okay. After that, let me go down. We need to create a build. Okay. Although I have the latest version, I will show you Docker images. And you can see this is the repository which I have created, and this is the old one. Okay, and I have the latest build. So even if I run, right, it is not going to do anything. Everything is cached, everything is in layer, and nothing is going to happen. Docker images again. See, 34 hours ago. So no change. I'm at least on the latest one. So now, after the build completes, tag your image so that you can push the image to the repository. This is the command which we need to run. So we have the image locally. Now we will tag it. Didn't get copied. Okay, I guess now it is done. Okay, we have tagged it. Finally, we push the image. Okay, right, it is preparing, pushing. So I guess we are almost done over here, because once this is done, the image will start showing up. And while this is happening, why don't I close this, open up a new tab, and in there, go to ECR, sorry, ECS. Container service, right? So inside the container service, now what I would like to tell you is something very important. So inside the container service, we have, first of all, the first layer, which is a cluster. Okay, the cluster which is managed by Fargate. Okay, the cluster has services. Okay, so in a cluster, you can have multiple kinds of services running, and each service runs a task. Okay, that's how it is distributed or divided, you can say. And the tasks are something which are equivalent to the containers which we have, because in the task definition you say how much RAM do you require, how many tasks do you want to run, so on and so forth, right? So we create cluster. Inside that cluster we have a service, and services run tasks. That's the nomenclature. Now what important thing is, and it's a very strange behavior I found on Amazon, is that if you create a task definition, okay, then inside that task definition there are revisions to it. Okay, you can change your task configurations, and it will create its own revision. So you can see there's the first revision, then there is a second revision. Okay, these kind of things happen, but there is no way for me to delete a task definition. I saw the forum. This thing is open for last 6 years. It is not addressed. So be careful about what name you put in. So because our application name is feature flag, what I have done is my task definition says feature flag task. Okay. So now obviously I can create from start, because as I told you, I can't delete it. You can see it has update service, create service, run task. There's nothing else, right? But what I will do is I'll create a new revision for you. Okay. Create a new revision, and I will go through what are the configuration steps which are available here. Okay. So task definition, obviously, this is the name of the task. I'm not going to change that. This is the role which was created on IAM. It has basic permissions, for example, launching containers. It has permissions for CloudWatch as well, because it needs to write logs to CloudWatch in case we need to see them. Okay. Then network mode, I have set that as AWS VPC. You should keep this as is. Then we are using Fargate compatibilities. Operating system obviously is Linux. Task execution role is also the same as this one. Okay. And in here, this is the very important configuration where we define the task size. The task size allows you to specify a fixed size for your task. Task size is required for tasks using the Fargate launch type and is optional for EC2s. Okay. So basically, container level memory settings are optional when size is set. So what happens is we are basically defining that how much memory we would like to give to each task and what is the CPU size. Okay. So let's say we select from this huge list. Obviously, I'm going to go with the least amount because it will be easier on my pocket. And what I will do is I can at least delete this container and I'll create this one. Okay, container name, let's just say we will do feature flag container, something like this. And here you should paste the URL of your ECR. Okay, actually this is not the URL, my bad. Let me go over here. Let me refresh because I think the latest tag is created. Right. This is the image URI. I think you should be able to get that from the previous screen as well. Copy this URI. And if I paste it here, this is the thing which it requires. Create a soft limit and port mapping. Now, port mapping is important. This is where we are saying which port from this particular container needs to be exposed so that any kind of mapping between the load balancer and the Fargate happens. This will be done on this port. And the simplest thing to do is just understand that we are exposing this port from our container, right? So that is the same port which should ideally come here. Then I'm not doing any advanced container configuration, but just keep a note that if you want to have, basic volumes and stuff in here, you can do that. But obviously I'm myself not that advanced, so I've just created the basic stuff. And yeah, that's how you add a container. Once you add the container, rest everything can be kept as is. Okay, so I'm clicking on cancel right now because I know this definition will work. And so we have our image on ECR, we have our task definition on ECS. Now we will go ahead and create a new cluster. So cluster is where the services are held together. Now in this we will use the Fargate one. We won't use the ECS2 Linux or EC2 Linux or EC2 Windows. We will use the Fargate version. Next step, cluster name, feature flag cluster. Okay, I'm not going to create a new VPC for this. In an ideal scenario, you would prefer to do a VPC because you will be setting all kinds of security stuff, what kind of internet traffic is allowed and everything. But right now we will keep this as unchecked because there is a default VPC with every AWS account and we are going to use that. If you want CloudWatch metrics, you can do that. I'm not going to do that right now. Just create and our cluster is created. If you go inside the cluster, you will see there are services, as I told you, and services can run tasks. Come on. Yeah. Okay. So for now, let's go to services again and click create. Now, a service lets you specify how many copies of your task definition to run and maintain in a cluster. Okay, that's the basic idea. And Elastic Load Balancer to distribute incoming traffic to containers in your service. So you need to understand that the service is going to handle the containers. Now I'm saying this is Fargate based, operating system is Linux, and this is the task definition. If you have multiple task definitions, you will get that. We have the feature flag task, the task definition that we just created. It was on revision 2, which is the latest. And you need to ensure that you click on enter a value. Platform version is latest. Cluster name is this. Service name, I don't think it is required. Let me see. No, some problem. It shouldn't have asked for the service name. Let me see. So I do Fargate and enter value latest. Something is not wrong. Let me click cancel. and try once more. The interfaces can be a bit buggy, I tell you. Okay. Service name, number of tasks is 1. Okay, now it is not saying it's a mandatory field, so I don't know what changed. Maybe I was doing something wrong. I don't know. Okay, so yeah, next step. Service name. Okay, so feature flag service. I think we can do that. At least it is not asking me for the service types and stuff. So yeah, next step. Now I need to choose a VPC, and let's say subnet 1A, 1B. You need at least 2 subnets, so do that. And then there is a security group. I have created a security group, which is feature flag services security group. And right now it is accepting traffic on port 80 from everywhere, which is fine because we are not running anything on port 80, but ideally I will change that. But for now, this is the security group. If you want, you can create a new one and just keep it as is, because we are going to change it a little later. Okay. I just need to ensure that I haven't selected the ELB one, feature flag service group. Right, this is the correct one. Auto assign public IP, although we don't need it because we are not going to interact with the services by default. The load balancer will, but yeah, for now, let's just keep it as is. I want to show you something. Right, this is the application load balancer thing where basically we need to create a load balancer first. So it's a catch-22 situation. Let's go ahead and first create the load balancer. So I'll go to EC2. We haven't created our service yet. The service needs the load balancer. So let's go to EC2. I don't want to do this. I'll scroll down, click on load balancer. Seems to be running a little slow, or is it my internet connection? I'm not very sure. Video is becoming a bit lengthy, I think. Okay, create load balancer. Should be doing a speed test to check. Name of the load balancer, feature flag ELB. It's going to be internet facing, IPv4. I'll take the default VPC. And in here, what all security groups do I have? I have create a new security group, maybe. Let me do that. So security group feature FEAT feature flag ELB SG. Okay. Scope is VPC. Interesting. Yeah, that's fine. Inbound rules. I'll add HTTP from anywhere and create the security group. Come over here, hit refresh, and where is our ELB security group? So we'll remove that. Now we have a listener here as well. One more catch-22 problem. We need to create a target group. So let's go to target group now. because a load balancer will not work without a target group. Load balancer needs to know when the traffic is coming, which target group to target basically. So yeah, things are a little complicated, but I hope I'm able to show you properly. So again, if you are getting confused, we have so far, first of all, updated the Docker image to the registry. Then we went into Fargate, ECS. Inside the ECS, we created our task definition. Task definition, you can compare it to a container. Okay. It's not exactly the container, but it describes the container. Okay. Task definition got created. We created a cluster. In the cluster, we were creating a service because the service will use the task definitions to create the containers. But then when we started creating the service, we understood that the service needs a load balancer. So we came into the EC2 section, and we were creating the load balancer. Now, while we were creating the load balancer, we discovered that we need a target group, and that's where we are. So let's create a new target group. It will be IP based. Now, this is very important. We are not going to do instances or Lambda functions or anything else. We should be using IP based thing. Okay. Now over here, the target group name is again feature flag TG. Here, the port should be 3000. So port 80 on load balancer comes to the target group, port 3000, request is forwarded to Fargate. Okay. VPC, only one VPC we have. So health check is fine. Next, remove this, and maybe ports for routing to this target should be 3000. I don't know why it picked up 2999. And create a target group. Let's see. This is now created. Let's come over here, refresh. We have our target group in here. And this is the summary, create load balancer. Oh, sorry, I need to select the availability zones. So I'll do 1A, 1B. As you must have seen, I did the same on my service as well. Okay. Now, okay, so now it is creating the load balancer. Now, creating the load balancer may take some time. It takes about 2-3 minutes. It will give us a DNS. So now, right now, if I hit this DNS, nothing is going to happen, right? So it is still provisioning. However, there's one thing. If you, obviously the DNS is not resolving and the containers are not directly approachable, but then we need to tell the cluster, the Fargate cluster, that it should accept traffic from the load balancer. Okay, this is important. Otherwise, the entire setup is not going to work. So what we will do is go to security groups, right? In here, we are going to deal with two security groups. One is feature flag service security group. This is where the traffic is going to come, and feature flag ELBSG is the you can say the place from where the traffic is going to come. Okay, this is the destination, this is the source. So I need to tell this destination what is my source. So let's click. We are inside that particular security group. Edit inbound rules. Okay. So in here, will it allow me to change this port 3000? Remove and the ELB security group. You may not specify a reference group ID for a existing IPv. I don't know what that means. If I delete security group TCP custom TCP 3000, select that ELB thing, right? That worked. Okay, and maybe what I will do is TCP. Okay, no, not now. I'll do that later, maybe. Okay, so we have a rule in our service security group, which basically allows an inbound rule to port 3000 from the source, which is another security group. So now let's see where we are with our provisioning. It says active. That's nice. Okay, so 503 service temporarily unavailable. So our ELB is now available, and let's see inside that. Listeners, this is fine. Feature flag target group. Wow. Okay, so these are configured correctly. I think now what I can do is go to ECS where the entire story started, and if I hit refresh, now I should see my load balancer. I'll see the container port thingy. This is my information which I need to put in. By the way, you need to ensure that you click on this button. Although this is shown in the drop down, but believe me, this is not done. Once you click on that button, you get this settings, production listener port, HTTP port 80. Target group is the target group that we had created. HTTP and all those things you can keep as is. Now with Fargate, we get the ability to auto scale, but obviously I haven't seen this so far, so I won't be able to tell you how that configuration works. This is the basic setup I have done, so I'll show you that. This is a review of what we have done so far. So let's create the service. It will do that, and now we should see ideally some tasks coming up. Yes, now it is saying that it is provisioning this thing. In some time it should get a public IP as well, although on that public IP will not be able to do anything. So pending. What happens if I refresh this? So far nothing is happening. Okay, it is still in pending mode. I think if it is taking some time, then I think the container is getting created. This URL ideally will not work because we haven't allowed the traffic, so this IP should not give us anything, and nor does the IP with port 3000, right? Right, nothing is happening. Anyways, I think the container hasn't started. Let me refresh and see. Yes, now it is working, and even now it says 503 temporary unavailable. Okay, this is a little weird. Let's see the load balancer. At least we should be able to see some traffic on load balancer. The monitors should tell us because these are 500 series thing, right? So let me see. Request count. It updates after a few minutes. So what could be happening? We have listeners. Let me open up the target group as well while I'm doing this. Description is fine. Let me go inside. So the traffic is not coming. Healthy, it says, is 1. IP address 10.0.1.251. Is that the private IP? Yes, it is. So containers are still running. Okay, so it took some time to give me the response, but I think the setup was correct. So as you can see, I'm getting the response exactly from what we had in our API, right? If you remember our code base, where is our controller? Our controller is returning the users and this service hello world. So if you see, what we have is an array. Inside that we have the users and then the hello world key. So this is how the entire setup is done. Again, I would like to tell you the flow is quite simple in terms of request, right? At the front facing, right, we have elastic load balancer. Okay. Below that, I mean, obviously it uses target groups. Let's just say, okay, like this, maybe. Okay. So the load balancer, the traffic comes in, it passes through the target groups. Now, target group knows that any traffic to port 3000, and this is, by the way, on port 80, right? So anything, any request on port 80 is passed to this target group. Okay, target group, what it does is it takes that and passes to port 3000 of Fargate. Okay, inside the Fargate, we have services running. Okay, the services has tasks, and these are our basically the containers, right? By the way, this is also called the cluster. A cluster basically is the collection of services. So yes, so load balancer port 80, target group 3000, it is carried here to 3000, and then the services get the request. All of this is happening because the cluster is using our image, which we have stored over here on this URL, right? And the beauty now, we have done so many things, but then the question may come, why this? Right? We could have done an EC2 instance and done the exact same thing. But the beauty of this entire setup is, first of all, you have a setup where, like in a typical EC2 instance, where scalability and reliability is a concern, right? We have load balancer, we have target groups, you can even have a firewall in between and those kind of stuff. So the front facing setup is quite similar. But then when we are ingesting the traffic from there, we have a lot of flexibility. First of all, we don't have EC2 instances, which means we don't need to worry about maintaining servers. Okay, we don't need to patch them, we don't need to do any kind of modifications. This is completely taken care by Amazon. Okay, and then obviously Fargate has its own auto scaling and stuff, which is very useful when you want to be in a situation where you quickly want to grow and then come back and remain very nimble about the servers. So yes, this is something which I have learned recently, and I'm definitely trying to put more applications into this kind of a format, because it really helps us. It helps us with less maintenance of servers, more confidence with security and stuff. So yes, I'm looking forward to it. I would like to know what you think about this architecture. Do leave your comments below. If you like this video, do click on the thumbs up icon and don't forget to subscribe to my channel.